Today we study the Calculus 1. The topic is Limit Theorems. So now look at the question. If fx and gx, the two limits exist, x tends to c, we will ask ourselves, how about the limit of f plus gx or f minus gx? If there are some relationship between f and g corresponding the limits. If f g is satisfying this expression, this means f less than or equal to gx and gx less than or equal to hx. And corresponding the two limits f and h exist and they are equal. And then how about the limit of gx? So now we try to answer these questions. Look at the theorem A. Main limit theorem. Let n be a positive integer, k be a constant. Limit fx and limit gx. If x tends to c exist, the first, limit k equals k. This means the limit of any constant equals itself k. The second, limit x. If x tends to c, c means some given number. At this time, x tends to c, the limit x is a number c. Look at the third. Limit kfx equals k times the limit fx. K is a multiplier. K is taken out from the expression. Pay attention to the number k. Now look at this. The limit f plus or minus gx equals the limit, the summation of the two limits, or the difference of the two limits. And then the limit f times g equals the product of the two limits. This one, limit f over g equals limit f over limit g. Pay attention to the limit gx doesn't equal 0. This means this expression has some mathematical meaning. Look at the last. Limit fx bracket n power. We can do the limit and then n power. The last one, limit fx the nth root equals the first do the limit, second the nth root. Pay attention to limit fx less than 0 if n is even number. Pay attention to the n position. According to the theorem, we'll look at the theorem B, substitution theorem. If f is a polynomial function or a rational function, and then limit fx, x tends to c equals the value function at a given point c, provided fc is defined. This means c is in the domain of fx. Look at this. The left side, limit fx. X is a variable. X tends to c equals the value of fx. This means x is substituted by the c. Note, in the case of a rational function, this means the value of the denominator at c is not 0. Look at the theorem C. If fx equals gx for all x in an open interval containing the number c except possibly at the number c itself, and if the limits fx and gx exist, at this time we have this result. Limit fx equals limit gx. Pay attention. The given condition fx equals gx. We will do the same operation, getting the limit. They are equal. Look at the theorem D. Square theorem. What means square? let f, g, and h be functions satisfying the expression fx less than or equal to gx, and then g less than or equal to h for all x near C point, except possibly at C. Why? Sometimes maybe C is not defined for the function, and then we will have this expression, limit fx and limit h. The two limits exist and they are equal. At this time, we can get the limit gx exists and the number is the same limit equals L. Look at the corresponding expression. It is given the expression if f and g, the limit exists, tends to L. At this time, gx squared. No other number, only tends to L. So we have this result. Limit gx equals L. According to the theorem, we will finish the following examples. Look at example 1. Try to find the limit double x full power x tends to 3. How to do? Yes, according to the main limit theorems equals 2 times limit x tends to 3. 2 is a constant, it's taken out. So times x full power. Full power, we can get the limit first and then full power. Limit x tends to 3 equals 3 itself. So we have equals 2 times 3 full power together. The final answer is 162. Now look at example 2. Try to find the limit this expression. How to do? The limit f over g. So we should determine limit g equals 0 or not. Look at this. Limit x tends to 2, bracket, x squared minus 5x plus 3 equals 1, 2, 3 equals corresponding the operations of the three limits. Limit x squared minus limit 5x plus limit 3. Go on. Limit 2 power, do the first limit and then square the second. 5 is a constant, we can take it out. Minus 5 times limit x plus limit c, c is 3. Together equals 2 squared minus 5 times 2 plus 3. Together 4 minus 10 plus 3 equals minus 3 doesn't equal 0. This means limit g doesn't equal 0. Means denominator doesn't equal 0. So this expression has the mathematical meaning. We can get the limit f over g equals limit f minus limit g together equals this expression. Final value equals minus 4. Try to remember the first step. We check limit g equals 0 or not. In this example, equals minus 3 doesn't equal 0. So now we look at the example 3. Try to find the limit f over g. In the similar way, we will check limit g equals 0 or not. The limit x tends to 1, bracket, x squared plus double x minus 3 equals 0. Why? I tend to 1. 1 squared plus 2 minus 3 equals 0. So we can get this equals 0. How about this? Limit 4x minus 1 equals 3. 3 doesn't equal 0. So we have this expression. X squared plus double x minus 3 over 4x minus 1 equals 0 over 3. 0 over any non-zero real number equals 0. Pay attention to the relationship, this expression and this. So we change the orders of numerator and denominator. We can obtain the original limit equals the change order equals 0, and again equals infinity. So the limit equals infinity means the limit doesn't exist. Why? Do you remember? The limit exists. It is some real number. It is infinity means some tendency, not a real number. Now look at example 4. Try to find the limit as tends to 3. We can check. Yes, it is limit f over g. Look at, how about f? H tends to 3. 3 squared minus double 3 minus 3 equals 0. 3 minus 3 equals 0. So it means 0 over 0 is there. How to do? According to factoring, we can write it. This expression x minus 3 times x plus 1 over x minus 3. Pay attention to. They are the same expression. We don't care the value of x. Anyway, they are the same expression. So according to factorization, we can delete the same expression. So equals limit bracket x plus 1, x tends to 3. So now the original limit becomes very easier. X tends to 3 equals 3 plus 1, so equals 4. Now look at example 5. If this expression is given, look at this. Sin x over x less than or equal to 1, larger than or equal to minus x squared over 6. It is given. It is like f less than or equal to gx less than or equal to hx. For all x near but different from 0 means near 0, close to 0, but different from 0. Why? If x equals 0, this expression no mathematical meaning, so we can give the condition but different from 0. Try to find the limit sin x over x tends to 0. How to do? Do you remember our squeeze theorem? So now, according to this expression, given condition x near 0 but different from 0. So we have this condition. X tends to 0. Look at this. We can check the left and the right. If x tends to 0, 1 tends to 1. Why? Yes, limit 1 equals 1. So tends to 1, the left. 1 minus x squared over 6. X tends to 0. So corresponding limit equals 1 minus 0 equals 1. Pay attention to, they are the same numbers. Together, we can get the middle expression corresponding to the limit exists and equals 1. Means by the squeeze theorem, we have the original expression sin x over x corresponding limit equals 1. So you try to understand the result. So now look at the summary. The first, do you remember the limit f plus or minus gx equals corresponding the summation or difference of the two limits? How about the times? Yes, the limit fx times gx equals times means the product of the two limits. The third, limit f over g equals limit f over limit g. Given condition, limit gx doesn't equal 0. Do you remember our example? If you do some questions like limit f over gx, you should check limit gx equals 0 or not. So now, according to our summary, we try to finish the questions. Look at the question 1. Find the limit x tends to 4 bracket 3x squared minus double x. How to do? Do you remember example 1? In the similar way, according to the main theorem process, we can get the first step equals 3. 3 is a constant we can take out. times limit x squared. Square taking out, do the first limit and then square. Minus double x limit. Double, the number 2 means a constant. You can taking out. So minus 2 times limit x together equals 3 times x tend to 4 means limit equals 4. So the answer means 3 times 4 squared minus 2 times 4. Try to get the final result equals 40. Now we look at question 2. Try to find the limit f(x) over gx. Do you remember some expression for the example 2 and example 3? In the similar way, we should check the limit gx equals 0 or not. So now we will check limit gx. X tend to 1, bracket x squared minus double x plus 1 equals 1 minus 2 plus 1 equals 0. This means limit g equals 0. And then, because limit x cubed plus 3x plus 7 equals 1 plus 3 plus 7 equals 11. 11 doesn't equal 0. We can check the limit x tend to 1 equals 0 over 11 equals 0. 0, and this time we should change the orders of numerator and denominator. We can obtain the following expression. Limit this expression. This means corresponding equals 0, change order equals infinity. Infinity, not a real number. This means the original limit doesn't exist. Because limit exists, itself should be a real number. So now look at question 3. Try to find the limit, a new expression, f(x) over gx. How to do? We will check. Yes, equals limit x tend to 2, factoring x minus 2 times x plus 5 over x minus 2 times x plus 3. We have the same expression. We don't care the values of x. The same expression we can delete, mean the same factor. So the original limit equals 2 plus 5 equals 7. 2 plus 3 equals 5. Together, 7 over 5. It is our final result. So now class is over. See you next time.